downrange 35 miles, 30 miles high. Standing by for the outboard engine cut down now.
Station. And ignition. Cut off the ignition. Trajectory up. Houston, front is go all engines. You're looking good. Roger, you're loud and clear.
At 3 minutes, downrange 70 miles, 43 miles high, velocity 9,300 feet per second.
We got third step. Roger, we confirm third step. Roger. Tower's gone.
Neil Armstrong confirming both the engine skirt separation and the launch scan tower separation.
Houston, be advised the visual is go today. This is Houston, roger up. Everyone converting is good. Yeah, how many getting your windows on the gas? Check that line convert. There you converge, Captain. 11 Houston, your guidance is converged. You're looking good. Can't say what's that. You can.
Downrange 140 miles, altitude 62 miles, velocity 10,300 feet per second.
We're good at 4 minutes, Captain. 11 Houston, you are go at 4 minutes. Right.
Apollo 11 right on the ground track.
We're great at go.
190 miles downrange now, 72 miles an hour, velocity 11,000 feet per second.
Water down that flight. Right. How you look, Bruce? Booster flight. Go light. No, look okay. At the front light up here. You sound flight. How you?
Booster says it's looking good at 5 minutes.
11 Houston, you are go at 5 minutes. Roger.
Downrange 270 miles, altitude 82 miles, velocity 12,400.
Stand by.
Welcome to the Jordan Hall of Science. My name is Keith Davis, and I am the director of the Digital Visualization Theater. Usually I say that in the Digital Visualization Theater, but today I thought we might have a much more interesting talk. If rather than me doing a lot of reading about the Apollo mission and how the moon worked, I thought we would get one of the world's experts on some of the Apollo return samples to speak for us today. So I wanted to thank you all for coming. There are a couple other things going on in the area, and one I want, in celebration of this, and one I want to bring your attention to. At the PHM Digital Video Theater and Planetarium, there will be a special event on July 20th, which is the anniversary day. Mindy, can you stand up and wave? She's the director of their planetarium. She has organized a huge event with a lot of activities that will be a lot of fun. So it's not a lecture like this is. It's more of a get out, do things, watch robots, make craters in dirt, like get a sense of play. So that'll be a lot of fun, I think, for all ages, but also geared largely to younger ages as well. So I encourage you to check that out. That is on July 20th at the PHM. And oh, they will also be presenting a new show at their planetarium called Imagine the Moon. That's an Adler production, right? Yes. Yeah, I've seen it. It's really nice. I think you're really going to enjoy that. But before we waste any more time, oh, also, if you want to stick around, I think the talk's probably about 40 minutes to an hour. We'll give a little bit of a break, and then we'll meet in the DVT afterwards for those that would like me to just do a little bit of showing what the moon looks like in that environment. But I think we're ready to go ahead and get started. So I want to give a special thanks to Clive Neal for being willing to be here and do this presentation today. He is a professor here at the University of Planetary Geology. And he actually has a video that's going to do a much more thorough introduction of him than that. So I'm going to leave that to give you his history and his experience with the samples and what makes him one of the world's experts in what he's going to talk about tonight. So thanks a lot for coming. Let's welcome our speaker.
I was 8 years old when Apollo 11 launched into space. I can still remember my father waking me at 4 in the morning to watch the first man walk on the moon. Seeing those images for the first time from another world was inspiring.
We got a beautiful picture now.
Over the next 3 years, the Apollo missions revealed so much about our moon. But when the last manned mission left in 1972, so many mysteries remain. Mysteries that we are still trying to uncover today.
Clive Neal is a professor of planetary geology at Notre Dame and the chair of NASA's Lunar Exploration Analysis Group. His research focuses on understanding the evolution and composition of the moon.
It took 36 years from when we last left the moon to discover there was water there. We simply didn't have the technology to be able to detect it. But once we did, it opened up a whole realm of possibilities.
Clive Neal is one of these rare people that we saw a few of during Apollo, and we have seen a few since. His work has advanced our knowledge in remarkable ways that not only relate to the use of energy here on Earth, but also to the exploration of the rest of the solar system.
Studying under Professor Neal has truly been a life-changing experience. I've had the opportunity to literally touch the moon, and the research I've done has given me the confidence to pursue my dream of someday working for NASA.
The Apollo landings inspired a generation of scientists and explorers, and my hope is that our research will inspire the next generation to push further into the unknown.
The University of Notre Dame asks, what would you fight for?
Fighting to explore the moon.
We are the Fighting Irish.
I'm still paying the bill to Harrison Schmidt for saying those things. So tonight I want to take you on a journey celebrating the past but looking to the future. And I'm going to wander around, so I may wander up the back just to check you're still awake. Because the last 20 minutes there will be a quiz. And yeah, I think I'm joking. So the important thing here is that this Apollo 11 was the greatest achievement of the 20th century, maybe ever. Taking computing power that is dwarfed by our cell phones these days and actually using it to land humans on the moon and bring them back safely, along with a bunch of really good rocks, but I could be biased there. So if we look at Apollo 11, July 20th, 1969, the first humans landed on the moon. 8 years later, my eldest daughter was born. You do the maths on that one. The three astronauts that went there only spent 21 hours, 36 minutes on the surface. And they brought back a treasure trove of samples. And Neil Armstrong was not a geologist, but they were told to get back in the lunar module to come back to Earth. And he said, hold on a minute, that rock box is not full. And he got a shovel and he shoveled just the lunar soil or regolith into that rock box to fill it up. One of the best samples ever brought back from the moon. It told us so much about the Apollo 11 site that really wasn't seen in the rocks themselves, because that regolith contained many, many different types of rocks from that area. And it gave us our first look at these samples collected in situ on another planet. So you can see there, 16th of July, Apollo 11 launches. That website, just going back here, at the bottom there is the website that I took that from. A friend of mine, Ben Feist, who's actually out of Toronto, has been hired by NASA to create these websites because he did the same thing for Apollo 17 in his own time. It was his hobby. And he got all the tapes of the audio, the video for the entire mission and has synced it up in real time on this website. And it is well worth taking a look through that. If you've got a spare 106 hours, you can go through the whole mission. But it is from start to finish on that website. It's phenomenal, a phenomenal achievement from Ben. But we're celebrating 50 years in a few days. 50 years. But did we actually go there? I hear this a lot. Surprisingly a lot. So just watch this. There we go. Any questions? So, but the thing is that NASA did stage the Apollo moon landings. Problem was the astronauts were such perfectionists, they demanded it be done on location each and every time. Maybe Apollo 13 didn't work out the way they thought, but they actually did get to the moon. They just didn't land on it. So what happens if you accuse an Apollo astronaut of faking the moon landings?
You're the one who said you walked to the moon when you didn't. Call the Shuttle block if ever thought. Say you represented away from me. You're a coward and a liar and a thief.
That is the producer of the Fox documentary about the fake moon landings, accusing Buzz Aldrin, the Apollo 11 moonwalker, of faking it. And you notice that Buzz is not a big lad, and he's punching up. He got sued for that, and he lost. He lost because you look at the Apollo, conspiracy theorists, and what do they talk about? The flag is waving. There's no atmosphere. Why is it waving? Well, if you've got no atmosphere and you've jiggled that flag, it's going to go back and forth until friction stops it. There's no atmosphere to stop it. The other thing they don't talk about are the samples. You cannot fake a sample to give you a 4 billion year old age in the lab. Because if you make it in the lab, it gives you a 0 year age. But we've got Lunar Reconnaissance Orbiter orbiting the moon right now and taking fantastic high-resolution imagery. This is the Apollo 11 landing site. And you can see the little lines, little dark lines. They are the astronaut footprints. You can see the lunar module. You can see it sitting there, the descent stage, because they came back. You can see the experiments they set up, and the LRRR is the laser retroreflector that was put up there so that we can shoot lasers to it from this planet and get a reflection back. And that is helping in many things that I know nothing about, things called astrophysics. It's not really doing rock stuff, but astrophysics. And that's the only ongoing Apollo experiment still active, still ongoing, present day. And it's showing that the moon is actually getting further away from us. And one day, it will be gone. But I don't think it's going to be in our lifetimes. So let me ask, hands up, who was alive and saw Apollo 11 land? Don't lie to me. Yeah, not many. Not many. We've had our Apollo moment. We need another one. Everyone should have an Apollo moment because it is life-changing. I change countries. This is not a Northern Indiana accent, apparently. But you may have already guessed that already. So we have pictures of the landings. We have samples back from the moon. And yet people will still, gave a talk with Jack Schmidt in Kansas City, and a person came up to me afterwards and says, I still don't believe NASA did it the way they said they did it. I said, why don't you ask the man who walked there? And the guy freaked out and left. Why don't you ask somebody who's been there? This is not fake news. But why did we go to the moon? And this is an important point, and I want to emphasize this. Why did we go? And why did we stop? So, history lesson. 4th of October 1957, the Soviet Union puts the first man-made satellite in orbit around the Earth, going over America. 12th of April 1961, Yuri Gagarin becomes the first human to orbit the Earth and go into space. And then we had 17th of April 1961, we had the Bay of Pigs issue, and then the Cuban Missile Crisis. Things were happening. Things were happening, and America felt like it was being left behind. I was still in England. Actually, 1962, I was only just in England. So, 25th of May, 1961, President John F. Kennedy gives an address to Congress.
Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth. I believe we possess all the resources and talents necessary, but the facts of the matter are that we have never made the national decisions or marshaled the national resources required for such leadership. We have never specified long-range goals on an urgent time schedule or managed our resources and our time so as to ensure their fulfillment. I therefore ask the Congress, above and beyond the increases I had earlier requested for space activities, to provide the funds which are needed to meet the following national goals. First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Expensive. There's a clue. This was all taxpayer funded, and we sent humans to the moon and brought them back and created careers for people like me. And I am an American now, so I'm not stealing from you. He further went on and gave a talk at Rice University, September 1962, 12th of September 1962. September in Houston. And he's wearing a suit. It blows me away.
There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind, and its opportunity for peaceful cooperation may never come again. But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
That boy could give a speech and give us a vision and try to give us a justification of why we should go to the moon. Why does Rice play Texas? You know, I didn't get that till I moved to America. But so we had a race. We had a space race. We had to beat the Soviets, and US is playing catch-up. National pride, and we needed something to get public opinion going with all the other things that were going on in that period of history. So less than 7 years later, we're starting to see Apollo 11 come together. We saw the launch earlier on, and the first humans landed and came back. But it almost didn't happen. Going to watch the landing video, and I want you to listen for 12:01 alarm, 12:02 alarm, 60 seconds and 30 seconds.
Go for landing, over. Roger, understand. Go for landing. 3,000 feet. You're looking great. How you doing, Control? We're looking here, fine. How about you, Telcom? Go. Guidance, you happy? Go. Right up. Go. 2,000 feet. 2,000 feet. Into the egg. 47 degrees. Roger. 37 degrees. Still looking very good. Your go. Stop alarm. 1201. 1201. Roger, 1201 alarm. 1201 alarm. Stand by, we're go, guys. Okay, we're go. We're go. Same time. We're go. Altitude 1600. Eagle looking great. Roger, 1202. We copy it. 35 degrees. 750. Coming down to 23. 540 feet and a 15. 150 feet down at 4. Altitude, velocity, light. 8.5 down. 220 feet. Out forward, coming down nicely. 200 feet. 4.5 down. 5.5 down. 100 feet. 3.5 down. 9 forward. 75 feet. That's looking good. Down a half. 6 forward. 60 seconds. Lights on, forward, forward, 30 feet down, 2.5, picking up some dust, big shadow, 4 forward, drift into the right a little, 30 seconds forward, just, contact light, okay, engine stop, we copy you down, Eagle, Houston, Tranquility Base here, the Eagle has landed.
The Eagle has landed. Now, 12:01 alarm. Computer can't handle the data it's getting, and it's putting the lander down in a boulder field. That's not good. 12:02 alarm, you need to reboot the computer because it can't handle it at all, and it's stopped completely. You don't have that much time. So Neil Armstrong grabs the controls, and he's manually flying the limb. You hear 60 seconds. That's how much fuel he's got left. Then you hear 30 seconds. That's how much fuel he's got left. So at about 23 seconds, engine's off. That was how much fuel was left before they had to abort. Almost didn't happen. Almost didn't happen. Just to think, to get that close, within 10 feet, and say, oh, abort, we're out of fuel. But if they had to have aborted, if they had ignored that, they wouldn't have come back. So it was pretty close. So let's fast forward, not really that fast. We look at the 14th of December 1972, the last Apollo mission. The last Apollo mission. We're going to explore why, but just listen to this.
Everyone remembers Neil Armstrong's first steps on the moon and the words he spoke. Few remember the final speeches just 3.5 years later. The task of summing up the Apollo program fell to Gene Cernan as he stood on the surface of Earth's nearest neighbor.
As I take man's last step from the surface, back home for some time to come, but we believe not too long in the future, I'd like to just let what I believe history will record that America's challenge of today has forged man's destiny of tomorrow. And if we leave the moon and towards Little, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind. 1, 2,
30 Houston, we're in the blind and we're go.
That's 47 years ago this December. And there's only 4 of the 12 moonwalkers left alive. Buzz Aldrin, Apollo 11, Charlie Duke, Apollo 17, Dave Scott, Apollo 15, Harrison Schmitt, Apollo 17. I think they all thought they would be seeing humans back on the moon before now. It's a great achievement. Why did we stop? All has to start with, why did we go? So I show this a lot, because it is stuff of science fiction. We have to reinvent what we'd learned a long time ago, because those systems aren't available to us today and have actually been superseded by technology. But we actually haven't built the systems yet to exist on another planet. So it is becoming the stuff of science fiction again. Hopefully it'll be science fact pretty soon. So, US had won the space race. As soon as Apollo 11 landed, victory. Competition over. Now what are we going to do? There was no long-term plan. The Vietnam War was getting expensive. The public had lost interest in the moon. Apollo 13, when it had the explosion on the way to the moon, it reinvigorated the public interest. But Apollo 17 was not televised on live TV. Politics, there's a thing. Kennedy was a Democrat, but Nixon was a Republican. So, Apollo 20 was cancelled after Apollo 12. Those rockets you see at Kennedy, Marshall and Johnson Space Centers are Apollo 18, 19 and 20. Some of the boosters were repurposed for Skylab. And then 18 and 19 were cancelled after Apollo 13. So, space station was thought to be affordable. Skylab went up. Fell on Australia, but whoops. Mars was the next destination. We had Viking 1 and 2. In 1989, there was the first real effort to get humans back to the moon with George Bush Sr., Space Exploration Initiative. However, it was a one-termer, and it was axed in Congress by the incoming Democrat. The Democrat axed a moon program. Sort of ironic. So then, his son, Junior, 2004, had the vision for space exploration in order to reinvigorate NASA after the Columbia Shuttle disaster. So this was to go to the moon, to go to Mars and beyond. It ended up being an unfunded mandate, and we had an election. And on 15th of April 2010, President Obama gave this speech. No, I'm not giving you all of it, just an excerpt, at Kennedy Space Center.
I understand that some believe that we should attempt a return to the surface of the moon first, as previously planned. But I just have to say, pretty bluntly here, we've been there before. Buzz has been there. There's a lot more of space to explore and a lot more to learn when we do. So I believe it's more important to ramp up our capabilities to reach and operate at a series of increasingly demanding targets while advancing our technological capabilities with each step forward. And that's what this strategy does. And that's how we will ensure that our leadership in space is even stronger in this new century than it was in the last.
History is cruel. All right? Abandoned the moon, and his strategy was to increase NASA's budget by $6 billion over the term of his presidency. It was actually cut by $714 million. So consequently, we went nowhere. Shuttle was cancelled. We can't even send our own astronauts to International Space Station. We have to pay Russia to do that. And we still have to do that to this day. What has happened? So President Obama's plan was a crewed asteroid mission in 2025. However, examining that, there were no asteroids close enough. They wouldn't be able to survive that long in space. So we'd be killing astronauts rather than sending them on a mission. So this morphed into the asteroid redirect mission, which started off to bring an asteroid to the Earth-Moon system, put it in orbit around the Moon, and then send the humans to explore that in orbit around the Moon. But then they couldn't do that. So then it was a 5-meter diameter boulder from an asteroid, bring it back, put it in orbit around the Moon, send the humans to explore it. But then they couldn't do that. It ended up being a 1-meter boulder, putting it in orbit around the Moon, and then send the humans to explore that. That's not going to be a very long mission. I'm just saying. So that has since been cancelled. So where are we now? We're going to the Moon, for now. Space Policy Directive 1 goes to the Moon, we learn how to do things, and we go on to Mars. Although he may have changed that with a tweet that came out a couple of weeks ago. Who knows? But the big difference, it involves the private sector. Now, when NASA went to the Moon, they had a lot of contractors, but they were contractors that were getting government money. The private sector in New Space is actually developing systems of their own, using their own money. Blue Origin, SpaceX, Intuitive Machines, so on and so forth. A number of new companies, what I call New Space, out of control. It's great. Jobs for our students when they graduate from Notre Dame. This is a whole new sector that's coming into play, and I think this, third time's the charm, this may get us back to the Moon with humans, and this time to stay. So, but wait, there's more. More intrigue at the National Space Council meeting on the 26th of March 2019, and this took everybody by surprise.
Just as the United States was the first nation to reach the Moon in the 20th century, so too will we be the first nation to return astronauts to the Moon in the 21st century. And I'm here on the President's behalf to tell the men and women of the Marshall Space Flight Center and the American people that at the direction of the President of the United States, it is the stated policy of this administration and the United States of America to return American astronauts to the Moon within the next 5 years. And let me be clear, the first woman and the next man on the Moon will both be American astronauts, launched by American rockets from American soil.
So where are we going? We're going to the lunar South Pole. I can give a whole another lecture on why I don't think that's a good idea, but I'm not going to. But that's where we're going, because on this side you can see we have peaks of almost eternal light. Lots of solar power. And then you see eternal darkness in these craters. And there's supposedly water ice in there. And we need water to live. We need it for a lot of things. Why is water important? Well, we can split hydrogen and oxygen, and we can have the oxygen to breathe. We can have it to sustain life. Most importantly, a meter-thick sheath of water is really good at protecting humans from ionizing radiation. Finally, it's rocket fuel. Liquid hydrogen, liquid oxygen makes a great rocket fuel, gives you the most chemical impulse per mass unit. So agencies need to look at developing these engines. And give NASA their due, their Space Launch System is liquid oxygen, liquid hydrogen. It's the biggest rocket ever being built, and because it's being done by Boeing, it's behind schedule. No, did I say that out loud? I can't say that out loud, sorry. It's being done by Old Space. That's what I meant to say. So, the thing is, though, what we've learned from Apollo and since Apollo is going to lead us back to the Moon. So the missions that have gone, Soviet Union had a few missions, a rover mission in 73 and a sample return in 76. US had Clementine and Lunar Prospector in the 90s, and then this century has just gone nuts. The light blue ones are the ones that are still in operation. The ones in parentheses are about to be launched. China and Chang'e 5 is going to be a robotic sample return from the lunar near side this December. Chandrayaan 2 is launching on the 15th in India and the 14th of July here. It's a rover going to close to the South Pole, 71 degrees south. So there's been lots of international interest in the moon. These are all robotic, no humans involved, of course. But Apollo taught us that the moon is a hostile place, but that soil or regolith on the surface, we can actually create water out of it. You heat it up. I've seen the experiment done with Apollo sample. You heat it up in a vacuum and water will drip out of the bottom of that bone dry material, which was what it was termed when these first samples came back. What happens is the sun continually hits that soil and it's implanting atoms and protons. Protons are hydrogen nuclei. So you expose that soil to the sun for a long time, you've got hydrogen there. You've got oxygen bound up in the minerals in the rocks. You heat it up in a vacuum, it reduces those oxides in the minerals to the metals, liberates the oxygen, and you get water that comes out of it. Now the mineral ilmenite is titanium rich and it's the moon's sponge because it likes to hold on to these materials. And over there on the bottom right you can see the red areas are the titanium rich areas of the moon. We know that. We know that. So we have the resource there to actually create life-sustaining water and maybe even rocket fuel just anywhere on the surface of the moon. Samples are the gift that keep on giving. The samples that were brought back in 71 by Apollo 15 and 72 by Apollo 17 were ignored, well not really ignored, but they were dry. Until 2008 when we actually had the technology to analyze these very small samples. And it was shown, if you look up here at the top left here, that's water, and on the left is the middle of that little glass bead, and on the right is the rim of that little glass bead, and it's a diffusion profile. There's water present in these samples, and we didn't know it until 2008. That's the gift that keeps on giving. Well, when that was found out, we started to look at orbital data, and we started to find a water signature in these volcanic deposits all over the moon. Wow. It was a paradigm shift in our understanding of the moon. Lunar Prospector gave us a hint that at the poles in these permanently shadowed regions, there was water ice. They termed it hydrogen deposits because they had a neutron detector and it detected neutrons coming out from the moon. As the solar wind hits it, it liberates neutrons. When you have water ice, it absorbs neutrons. So as you go over the poles, you can see there are dips in the top left here at the North and the South Pole. Lunar Reconnaissance Orbiter confirmed that with their neutron detector as well. We had our first real ground truth with LCROSS mission, which went up the Lunar Reconnaissance Orbiter and impacted into Cabeus crater. One of these that had this neutron pore signature where we think there was water ice. And then as that plume came up, we used the light of the sun to reflect through it, and we actually measured just over 5.5 weight% water in that plume. Then we look at the latest discovery. It's integrating lots of different data sets that we've got from around the moon, and those little dots represent a reflection or at the surface where we think there's 30 weight% water ice at the surface of these permanently shadowed craters. Now, these permanently shadowed craters, their average annual temperature is 40 Kelvin, minus 233 Celsius. It's a little chilly. So there's going to be a challenge trying to get there to try and harness that. But what did we learn from Apollo? It's encapsulated right here. The moon is a little damp. There is water up there that can be used for life support. The moon is a hostile place, but we know that the resources are available on and in the moon to allow humans to live there. This is no longer science fiction. We know it's there. So why do we need to go back now? I've shown you the potential, very briefly, of the moon for sustaining life and actually having a lot of resources there. And the commercial sector is ready to participate, and they're very, very interested in mining the moon and using those resources. I'm running a lunar resource workshop next week, and we've filled the building. We're at capacity. It's the biggest workshop on this subject ever about the moon, because a lot of commercial interest. Can we make money out of it? And so this is a new sector for job creation, potentially. I want the graduates from my department, when I say, what are you going to do after Notre Dame? Oh, I'm going to go work on the moon. Wouldn't that be brilliant? This can happen. This can happen. So in situ resource utilization, or ISRU, is going to be a game changer. We've got to learn from history, though. We go back to the moon not in competition, but in cooperation. We know competition doesn't work. Apollo proved it. And that's what I like to say about Apollo. Apollo was absolutely brilliant, because it also showed us how not to do human space exploration. You don't do it in competition. You look at International Space Station, 30 plus years through international cooperation. There are lessons to be learned. I do not want to get in a race with China, because competition doesn't work. Cooperation does. So space agencies then need to be generating data that will allow companies to build business plans. We need to change the paradigm. We don't do human space exploration like Apollo anymore, or space station. They need to create markets for these commercially provided products. So we need to bring the moon into our economic sphere of influence, then Mars, then asteroids. This is multi-decadal vision. We go out into the solar system, and quite frankly, we don't come back. It can happen, and it starts with the moon. The big thing is, because as I said, Apollo was all taxpayer. That's an investment in our future. It's not a drain on the economy, it's an investment in the future, and we need to do a better job of showing the return on those investments. Everybody see what that is? Yeah, thank you, Apollo. Miniaturization of electronics. And it'd probably do a better job of landing the Apollo 11 module, but that's a whole other story. So, if we're going to go and send humans out into the solar system, the plan needs to be human permanence off planet. It's the only way you're going to generate the commercial sector to give them stability over the long term to build business plans, create infrastructure, and gain investment. So, the return on investment. I just listed a few here, talked about the smartphone from Apollo. These are some of the things that came from Apollo. There's quite a bit. If we look at the Artemis era, which is Apollo's twin sister, so they've called the new program Artemis. So cure for osteoporosis I highlight, because I'm getting old and the bones are creaking. You send astronauts out into microgravity for long periods of time, their skeleton dissolves. They come back, their bone density is way down. You send them out there for several years, don't bring them back because they won't live. They'll just be a blob. This is how we get a cure for osteoporosis. That's how, by investing in space technology, we actually make life better down here. Energy efficiency, closed loop life support, the ultimate recycling. And I put fusion technology there because this is for the future. If we look at the moon, diagram on the left there shows the amount of titanium and the amount of helium. Now helium, we've got a lot down here, helium-4, the isotope 4, but on the moon there's this isotope helium-3. We don't have much of that down here because it's a solar wind implanted species. Theoretically, you fuse 2 helium-3s, you get a helium-4 and 2 hydrogen, or 2 protons. And an awful lot of energy, theoretically more energy than you put in. Think about that. Now the calculations have been done, and Harrison Schmitt was at the forefront of this. He's the Energizer Bunny. One shuttle bay cargo load full of helium-3 would fuel the United States for 1 year. 1 year. I think there could be a business plan there, but we need to invest in fusion technology. Chinese love it. Their first two orbiters, they actually tried to get maps of helium-3 on the lunar surface using their microwave radiometers. They've produced maps that show where helium-3 is. I don't believe it because you don't see how they calibrated data. I'm getting sciencey. I'll stop. So the message then. We know that there are a lot of resources on the moon, but are they reserves? So geology speak. Resources means we know that this particular environment should contain these types of resources. We don't know if they're there, they are there, oh, that looks good. We need to know how much, what form is it in, can we actually extract it? Can we extract it economically? What is the market? So it comes back, space agencies need to be creating the markets for these, and we need to go out and find out if these resources are actually reserves. Good old-fashioned geologic prospecting, field work on another planet with the mule in tow. Maybe not have that, maybe a robotic mule. So, the moon started with Apollo. We learned a lot from Apollo. We learned how not to do human space exploration. So we need to learn from history. Start the cooperation. We now figured out, because of those subsequent robotic missions, that the moon is really an enabling asset. It's a new sector of the economy waiting to be started. This is what space agencies should be doing now, in my opinion. Kickstarting that new economy. We have a new sector where our graduates can go live and work successfully, and come back even, maybe. The technologies that will need to be developed will directly benefit life on Earth. This is not a drain on the taxpayer. This is an investment in our future. It's going to create this new sector of the economy. It will show a return on investment. And it needs to be planned that way from the beginning. Cooperation, not competition. But maybe the biggest thing, this is going to fulfill the legacy of Apollo. Why did you go for 3.5 years and stop? And I think I know why we did that. Why don't we just go and keep going? Because it's expensive. But there's a way around that too. Thank you very much.
Yes. Yeah, is the conference that you talked about that's upcoming, is that going to be held at Notre Dame?
No, it's actually held in Columbia, Maryland, because it's closer to Washington, D.C., and we can get NASA people to show up.
From the Applied Physics Laboratory there?
No, it's actually at the what is it called? University Space Research Association headquarters.
Okay, thank you.
So.
Sorry,
I will. Sorry. The question was, is the ISRU workshop I was talking about going to be held at Notre Dame? No, it isn't. It's going to be held in Columbia, Maryland. Yes?
Is there any work currently being done to develop the systems that are necessary, or is that still like just future planning?
That's, the question was, is there any work being done to develop the technology necessary for this next stage? There's been a lot of work being done, but it's been bootlegged on other projects. We're hoping that this workshop next week will actually start to give direction to actually get those technologies going. They're working on a spacesuit. We don't have a spacesuit that will work on in gravity. Moon has 1/6 gravity, but it's gravity nonetheless. It needs to work on a surface. So that's hopefully being fast-tracked if we're going in 2024. The Space Launch System is woefully behind schedule. And the taxpayer has pumped billions of dollars into that. So this needs to be on schedule. Now, the next thing is that NASA has announced a commercial lunar payload services program where they are contracting in a fixed price contract 3 companies, Orbit Beyond, intuitive machines and Astrobotic to deliver payloads to the lunar surface. First payload is going next year. And this is a paradigm shift because they're saying, if you do it, here's the money. If you don't do it, there's no money. This is different. It's not, oh, here you go, here's another check, here's another check. And if they're doing it for $200 million, which sounds like a lot of money, but you look at one of the cheapest missions to the moon is $400 million if NASA does it. So, yeah, that's the lunar surface. So this is a paradigm shift because the commercial side have come in and said, we can do it for cheaper. And we can get the same result. So this is great because it's shifting from government does everything. Because if government does everything, it's not going to be sustainable. If you are creating jobs in that, that's what the government should be doing, not creating jobs in government, but in the private sector. So this is great. This is the start. And I'm really excited, especially with this new administrator, Jim Bridenstine. He's a breath of fresh air because he's not a NASA insider. He's a politician, but it's different, let's put it that way. But he has new ideas.
And one more question. Maybe you can give some insight as to why the space shuttle program was stopped. I mean, you hear all these different things, but it really doesn't make sense.
Well, do I have any insight as to why the space shuttle program was stopped? I think first and foremost, we lost two of them. Apollo, we got lucky. We almost lost a mission, but we got it back. Space shuttle, we lost two. And the American public is, I'm afraid, they think it's easy. Space is easy. It's not. People are going to die as we go out into the solar system. It's going to happen. And I'm sorry, we're going to have to live with it, if that's the vision. Because these are pioneers. How many people died going from the east coast of America to the west coast? You know? But it's not televised. It wasn't televised then like it is now. So it's sad, but that's the risk you take, and the risk you pay is that space is hard. It's an environment that we're not used to. Crossing the street in New York is probably harder, but that's that's my insight there, is that we're very risk averse right now. And the other thing, if you look at the average age of people working at NASA during Apollo, 27. 27. They didn't know how to fail. So I made the suggestion that mandatory retirement at 50 for people at NASA. All my NASA colleagues who are older than 50 didn't like it. Do I still get my government pension? But yeah, that's what I think about the shuttle. As I say, they were an aging fleet. We didn't have the money to replace it, so we had to build something else, and we went back to throw everything away. Space Launch System is 100% throwaway. Going to go there, and then down there, and then over there.
Is the moon protected from solar radiation by the Earth and its magnetic? No.
You get in the magneto tail, but you are unprotected from radiation on the surface of the moon. That's why water is important. No. It's hostile. And that's why you say, well, why aren't we doing this on space station? Space station is not the moon because the radiation environment is very benign compared to the moon. So we need to get out of low Earth orbit and find out how to do it.
How would any permanent colony on the moon or Mars be incorporated into international politics? With governments not being able to lay claim to outer space bodies.
You want me to talk about politics?
Who would be responsible for these people?
It's a good question. It's a good question.
Would they be Americans still? Would they vote?
Well, you think when America went to the moon in Apollo, they went for all mankind. And womankind too. So they went for everybody. It was watched around the world, even in the Soviet Union. It's the way it's got to be. That's why cooperation, not competition, will enable those sorts of polities to be sorted out. But as soon as one goes up there and stakes a claim and say, that's mine, then we're in trouble.
So do you envision like the moon becoming its own political entity that has to protect itself from?
I think more along the lines of an Antarctic treaty. I mean, we have an example down here with Antarctic, so I think that would be the way to go, at least as a start. But then when you see, you don't mine in Antarctica, but we need to mine on the moon. There's the wrinkle.
What do you think the role of NASA is in new space? Should they really be designing the SLS?
What do I think the role of NASA should be in new space, and should they really be designing the SLS? This is live streamed and recorded, so I've got to be careful. Okay. SLS, when it was designed to be a replacement for the space shuttle, and it was the design was started over 10 years ago. We hadn't seen SpaceX's videos of those boosters coming back down and landing and being reused, and oh man, all right. And now we've got SLS, the biggest rocket ever designed, that will cost at least $1 billion per launch. 1 billion with a B, maybe more than that, because everything is throwaway. Nothing is reusable. That's the problem with SLS. Do we need SLS? Right now, there isn't any commercial heavy launch vehicle that can come close to it. So right now, we need it. But there are designs from Blue Origin and SpaceX. I prefer Blue Origin because they use LOX hydrogen engines. SpaceX uses LOX methane, so I can't talk to them. But that's hopeful. NASA should be getting the data for science and exploration that will enable businesses to create business models. It will enable scientists to explore the origins of whatever. Understand where the resources are, how do they form, what do they get there? And if you look at the data that is needed to look at water ice, data for science, exploration and commerce are essentially all the same data. There's nothing special really. So we do a science mission to explore South Pole for water ice. It's going to inform commerce, it's going to inform exploration. Can we use it? Can I make a profit on it? So that's what they should be doing, and then they should be creating markets for those products. That's the role of not just NASA, but JAXA, European Space Agency, Roscosmos in Russia, CNSA in China. So, well, that's run by the military. There's a bit of an issue with that. But those are the things. There's an old geology saying, and there's a dinosaur on a t-shirt, and it says, evolve or die. And that's what happens. You have to evolve, otherwise you're going to go away. And maybe not die, but you become irrelevant. So.
I was wondering if you're willing to expand on your H3 data comment a little bit.
Oh, helium-3?
And then part 2, where do you think that would be in terms of the priorities of this long-term plan?
Right now, it's not a high priority because the technology is not around to use it. Yeah. It's hypothetical. But it's clean energy. There are no toxic byproducts as you get from fission, which we have to store for 10, 20,000 years at least. All right? Chernobyl gives you an idea of what can happen. So if there was investment in the technology and it was proven, I think there would be a helium rush to the moon. And China is eyeing that because of that energy resource. And they actually had a sustained fusion reaction. It wasn't for very long, but they actually got to the point where they were getting more energy out than they were putting in. Lasted only a few milliseconds, but it's a start. And they're investing in it. And that's why they like the moon. They're looking to the future. So I think it needs to be a priority, but whether or not it becomes one, I don't know. But it's part of the resource package. As you're prospecting for water ice, you should be prospecting for helium at the same time. A variety of different things. So we have the data. We know where to go, when, if and when we need it. We go there and then up to there. Yeah.
Yes, the analysis of the lunar samples, as far as the heavy elements, exotic element like palladium. What's the potential there?
Okay, our question was, what's the potential for the precious metals coming back from the moon? Lunar samples are depleted in precious heavy metals. Meteorites are not. And the moon, if you just go outside and look at it, it's had the snot beaten out of it for 4.5 billion years by meteorites coming in. There's some people have hypothesized that these magnetic anomalies we see on the moon are actually buried metal asteroids within the regolith, which is going to be a huge, how you prove it, I don't know, because how deep are they buried, we don't know. But if it is true, then there's a potential there for actually mining that material. If you look on the near side of the moon, the biggest hole in the upper right, as you're looking at the upper left, is Imbrium. That is enriched in rare earth elements and thorium and a few others. Rare earths are sort of important. How enriched, where are the deposits, we don't know, we've got to go prospecting. Okay?
Apollo era had kind of some problems with personnel, but they had a stable base of like people working on the rocket. I read an article yesterday that a key personnel was let go because they weren't helping the rocket or SLS move as fast as once. Do you think turnover in personnel will have, or how will it have an effect on its speed?
If you're not helping the process move along, you're a roadblock, and you need to get out the way. And a good boss needs to figure that out and make it so. Otherwise, you are wasting taxpayers' dollars if you work for NASA. That's my thought on that one. Key personnel that buy in to the program are important. Everybody was vested in Apollo. They were young. They didn't have so many years of, I'm stuck in my ways now. Well, this is the way we do it. They were inventing the way to do it. Now we need to evolve that method because technology has moved on, society's moved on, so it would be very good to move on with it. Evolve or die. And that person that you're talking about, or the two people you talk about, had a very long history with NASA. Yes?
I want to go back to the payloads that you mentioned that are, privately financed. Are they going to be landing on the moon?
Yep.
And if so, are there any controls in place to make sure there's no contamination of either microbes or substances
Doesn't
that
matter.
might screw up our future?
Doesn't matter. Doesn't matter.
Doesn't matter.
No, I think the most sterile place is the surface of the moon.
But are we going to introduce anything?
We already have to.
We already have.
If you looked at that image of the Apollo 11 landing site, you see 3 footpads. The 4th one is covered up with the waste bags that they pushed out and went down. Same with Apollo 17. There were 4 feet. They covered up with the waste bags, human waste bags. So we've contaminated the moon, if that's the case, but they're not viable. It's a pretty hostile environment. So, yeah.
How do you see the far side of the moon being incorporated, if any or at all, in the Arctic era?
Apollo 20, they tried to get Apollo 20 to go to the far side. It was deemed too risky back then. Depends how long Artemis lasts. I mean, China has just proved that they can, we can land on the far side of the moon robotically. And Chang'e 4 and U-2 is the rover, still going strong. Been there 8 lunar days now. So it can be done robotically. We need to explore the far side, but the only thing that would be logical to put there is a radio telescope, because it's radio quiet there. There's a lot of noise from this planet. And my astronomy friends tell me that with that we can see back to the dark ages of the universe, right after the Big Bang. So with a radio telescope, there's certain frequencies. This is outside my realm of expertise, but that would be, whether or not you need humans there, I don't know. I don't think so. So
as we're including more private companies into space exploration, at what point do you think their role might actually hinder our progress forward? Like, how do we assure that our ideas and our goals are the same between, let's say, NASA, government agencies and private industry?
Well, cooperation again. So the question was, and I keep forgetting to repeat the question, so sorry everybody. How do you see the role of government and private industry working together? Will too much private industry, and correct me if I'm wrong, will they tend to sort of work against what our ideas are right now? Is that basically? So it's the cooperation part that comes into play in the communication. When I was chair, I'm no longer chair of the Lunar Exploration Analysis Group, but I constituted a commercial advisory board, and we started out with six members on that commercial advisory board back in 2015. There's 48 there now, because they see an opportunity. And it's not the fact, oh, I can get a contract from the government. No, they see a long-term opportunity in payload delivery services, communications. Am I going to, resource extraction and utilization? So there's opportunities there now. And quite frankly, if you look at the private sector in terms of rocketry, they've had good ideas. I'm not going to say better than NASA, but they've had really good ideas in terms of reusability. Shuttle was reusable, but it got cancelled. They've taken that and they've said, right, what about a conventional rocket? Let's make that reusable. So these are the types of the recycling and how it's going to benefit down here on Earth. Closed loop life support. No more sewage plants because we're recycling everything. You have that in your house, built into your house. Interesting. But that's where it could lead. It's the ingenuity that's needed and the inventiveness and the political will and the drive to make this happen. But space is hard and it's expensive initially. So it's the multi-decadal plan that's important, and showing the return on investment continually so the public don't lose interest and they understand and are educated as to what is the payback for this taxpayer investment. Jobs. Nick.
Yeah, do you view missions such as that James Webb Space Telescope that are taking a couple $1 billion and been delayed several times, and they're just taking
couple of billion
observations? Do you view those missions as less essential if we don't understand our own solar system?
James Webb Space Telescope will replace Hubble. Hubble has been transformational in our understanding of the universe. So it's important. James Webb Space Telescope is what? Oh, I can't even remember what it is now. Many billions of dollars over budget. And it's delayed a lot. Maybe it should have been cancelled, but now there's too much invested into it to cancel. So we've got to get it off the planet. Got to launch. Trouble is, we need SLS to launch it. Oops. That's also behind schedule and over budget. So comes a point where maybe you should say, it wouldn't be very popular. It's unfortunate, but project management. How long have I got?
We're about 5 minutes after 8, so maybe a couple more questions.
All right. Go ahead.
You said you had a strong opinion on South Pole exploration?
I said I had an opinion. Okay. Well, South Pole has Shackleton crater, which has a rich deposit of water ice in it. And so you put a base near a rich deposit, it's really good. It's in a peak of eternal sunlight, and then the deposit's in the darkness, so there's a temperature issue. But you can keep everything cryogenically frozen by just keeping it in the shadow. But you can get the water out, or can you? It's about, I think Shackleton is 3 or 4 kilometers deep with a 30-degree slope. Also, Apollo showed that there was a form of moonquake called a shallow moonquake that are, we don't know how they form, but they are the largest moonquakes that were recorded. There was 7 of them between magnitude 5 and 6. Now a moonquake, the moon reacts very differently to shaking. Here we get 30 seconds, minute and a half, and everybody's freaking out and stuff's falling over, and then it stops. On the moon, maximum ground motion lasts 10 minutes. 10 minutes before it starts slowing down. And people don't read the literature from the 1970s because it's old and I can't get it online, so it can't be real. But if you read the literature, they think around the South Pole region is one of these epicenters for a shallow moonquake that was a large one. But we're going to the South Pole. That's okay. It's on the moon. We can always move it, but not the moon, just the base. But that's why. And are those resources actually reserves? Can we actually economically extract them? Can we even get to them? So, South Korea is launching next year, 2021. And they have a shadow cam is the instrument from US, and that is supposed to take centimeters per pixel images inside these permanently shadowed craters. So we will get good maps within there, and then we'll know, can we at least traverse these areas? We're going to freeze, but can we at least traverse? I mean, 40 Kelvin's chilly. Makes that vortex we had look like a summer's day. So yeah.
Last question. One of the theories to come out of examination of lunar rocks from what I've read is the giant impact hypothesis for the moon formation. Could you speak a little bit, without necessarily getting too technical, what is it about those rocks that leads us to believe that it's composed of material both of the Earth and not of the Earth?
Okay. If you look, it is not a geochemical argument. The question was, giant impact hypothesis for the formation of the moon, and how do we know that could happen, or that did happen? How do we get that out of the samples? So that posits that a Mars-sized planetesimal smashed into Earth, and everything flew out, and then the bits that accumulated around Earth formed the moon. Now that actually comes from the moon's orbit and its angular momentum, rather than an actual geochemical argument. But when we look at the rocks, we find in a lot of cases the chemical compositions of those rocks are very similar to what we get from Earth. But we had a foreign body hit Earth early in the solar system. Well, that means then that foreign body must have also formed in the same vicinity from the Sun as Earth. Well, how do you do that? Well, it's gravitationally unstable. So it's a hypothesis to explain the angular momentum in the orbit of the moon. But when you look at the rocks, and rocks don't lie, honestly, they really don't. You can see that there's issues with that, there's questions with that, and this is what scientific investigation is now doing. How do you get the same composition? So there's talk about, we have mixing in the nebula, we have mixing here and mixing there, and it's very arm wavy. So maybe we need more samples from the moon to answer that. So
it's simpler, but not.
It's similar, all right, and it shouldn't be if you had another planetesimal hitting the Earth and they actually morphed to form the moon and big Earth now. Okay? Well, thank you very much. One more thing. My colleague who runs the Lunar Reconnaissance Orbiter camera sent down some swag here. So we have pictures of Apollo 11 and the LRO Apollo landing site, and then whatever that says there. I can't have my glasses on, but there's a nice impact crater. And if you are a school teacher, or else you get first dibs on the posters, because we've got some nice posters here, not many of them, but they are showing pictures of the Apollo 11 landing site as it exists, well, last year or the year before, taken from LRO. So thank you very much. Thank you.